Hi ladies and gentlemen, this is Mr. Green again. This is another of my lesson videos on Algebra 1. What are we looking at today? Well, today we are looking at graphing inequalities. Now, remember, an inequality is not a whole lot different than an equality. It just has a different sign in it. Not a big deal. We're going to treat it the same way. We're not going to do anything special with it, except for when we go to graph it. And I'll show you all about that in just a second. Okay? So there's going to be a procedure we're going to use. One, we're going to graph the linear equation using the slope-intercept form or the point-slope form or whatever form you want to. We're going to determine the equation of a line using the slope and the y-intercept, and then we're going to transform an inequality so that y is alone on one side. Okay? So several things going on there. I'm probably confused you with that. And then I'll show you how to decide which side to color on. We're going to get to use crayons. Yay! Crayons get to color on one side of the line or not. Now, the big deal with graphing of inequalities. We go ahead and we get the line just like we've done before at the point slope, the slope intercept, or the two intercepts. It doesn't matter how you get the line, you're going to get the line. There are two things that they're looking for. Whether the line is solid or dashed, and which side is shaded. That's all you have to remember about graphing inequalities. You're going to graph them just like they were lines, except you have to remember these two additional things. Not that big a deal. Now, how do we determine whether it's a solid line? You're looking for the little thing right there, which means or equal to. That little thing right there, or equal to. If it says or equal to, you make it a solid line. If it doesn't, if it's strictly a greater than or a less than, it's a dashed line. And we do count off points for that. So if you don't see that dash, if I don't see that dash line, you're not going to get the full credit for the line that you're trying to graph. Okay? So here's an example of a dashed line. How did I do this? Well, the first thing is this one was in standard form. So I found the y-intercept by putting a 0 in for x. Okay? When I put a 0 in for the x here, it comes out to be 3y equals 24 or y equals 8. That means I have the point 0, 8. So I went over 0 and up 8 and put a point right there. I then found the y-intercept by putting, the x-intercept by putting the 0 in for y. When I put a 0 in for y, I get 4x is equal to 24, or x is equal to 6. So I went over 6 and up nothing, put a point right there. I now have 2 points. I look at my inequality. It is a strict inequality. It's got a greater than sign. Dashed my lines. Just like that. Now the question becomes, which side do I get to break my crayon out and color that side? Well, I'm going to pick a point that's not on that line. Some point, it doesn't matter which point, not on that line. Let me show you. That point right there is not on that line, 0, 0. So if I come up here to the equation and put a 0 in for x, I get 4 times 0 plus 3 times 0. Well, that's 0. Is 0 greater than 24? Is that a true or a false statement? This is the key thing. True, shade the side of the point. False, shade other side. Does that make sense? I mean, I have to either shade the top half here or the bottom half of this line. If this point doesn't create a true statement, then I want to shade the other side of the line because that's the side of the line that'll give me a true statement every time. Now, why did I pick 0, 0? Because in case you didn't notice it, if I stick 0 in for x and 0 in for y, I get 0. That makes it easy to do the comparison with. That's so easy to do the math with. That's why I used a 0, 0 to do it with. It makes it a little bit easier to work with. Okay. So it says graph this following inequality, this one right here. Then identify the solutions to the inequality. Well, you know what? This is not that big a deal. I see this equation right here. I need to look at it in one of my forms. This is not any of those forms. So step one, I'm going to divide by 3. When I divide everything by 3, I get this equation right here. Well, I know by graphing lines, I'm going to start at -2, coming down from my graph to point -2. Put a point right there. My slope is 2 over 3. That means I go up 2 and over 3, put a point. Connect the 2 points. Am I going to connect them with a solid line or a dashed line? Look right here. I see greater than or equal to. That means it's going to be a solid line. So I just draw a solid line there, just like that. Step 3, pick a point not on the line. Well, 0, 0 is not on the line. That's an easy one to pick. So I'm going to say 3 times 0 is greater than or equal to 2 times 0 minus 6. So this is 0 greater than or equal to minus 6. Is this true? And the answer is yes, that is true, Mr. Green, because 0 is greater than -5, -6. Sorry, it's greater than -6. So I would shade the side of the line that has 0, 0 on it. And I get to break out my crayon and color a little bit. Woohoo! Okay, that's 6. Cool. Everyone see how I did that? It just is a matter of picking a point, deciding which side to shade upon. Hopefully that all makes sense to you, and I will talk to you next time. Remember, we're getting close to the end of the unit, so if you've got questions, come to tutoring. Make certain you're coming to Class Connects, because that all adds up in the end. I'll talk to you next time.